The concept of continuum. Continuum is a concept of considering the continuous distribution of matter. Just imagine a space and it is filled with air. So we are considering the air is continuously filled. It does not have any hole or any void in that space. Just let us imagine a figure or diagram like this as a first case. Now the atmosphere is filled with air. A butterfly is flying through it. So butterfly needs air. And if the air is present, mean it is easy for the butterfly to fly through it because the wings of the butterfly flaps against the air and hence it can move easily in it. Consider the second case. Now the butterfly is flying. When it encounters a hole like this without air means it will be difficult for the butterfly to move through it since it requires air in order to flap against it and to fly. So in such a case, that is in this case, when there is a hole without air means butterfly will feel difficult to move through it. Consider the third case. Filled with air, now the butterfly is flying. When it encounters a hole without air, but the size of the hole is much smaller than the size of the butterfly means it won't be difficult for the butterfly to fly through it. Okay, it will be easier. Consider like this. Holes are present here and there with much more distance in between them. So it won't be difficult for the butterfly to move through it since the holes without air is much more smaller than the size of the butterfly. So we have now seen three different cases. First case, the atmosphere is properly filled with air, that is continuously filled with air. The second case is there is a hole without air, which is the size of that hole is much bigger than the butterfly. And third case, the holes are there without air, but the size is very small than the butterfly. So the third case we can approximate as that of the first case. We can just imagine or we can approximate it is distributed with continuous mass. With this understanding, let us move to the continuum concept. Just imagine a space like this provided in the display. A molecule is present. Consider a second molecule. Now, if we consider the first molecule is going to collide with the second molecule like this, you can see the space between the two molecules is small in comparison to the size of the molecule. So in such case, we can consider the space to be continuum. Just imagine like this. A more number of molecules are there. So definitely one molecule will be colliding with other molecule and like that more encounters will be there. In such a case, the distance between the molecules, that is the distance traveled by a molecule when it is smaller than the size of the molecule means we can consider the space is uniformly distributed even though there is space between the molecules. Such an approximation is called as continuum. It is because more number of molecules are present. So even though there is space between the molecules, but that space is much smaller than the or in comparison to the size of the molecule. So we can consider the space is evenly distributed or continuously distributed with matter. So it is an idealization. It is an idealization or approximation we consider. Next one, this assumption also says that there are no holes or cavities or no voids in the matter. This concept allows us to take a macroscopic point of view. No need to bother about the molecular level activity. So we can do easily the problems or what we call as classical thermodynamics. We can do problems in classical thermodynamics without any difficulties. And let us say an example. The measurement of pressure shows that we are not worried about the pressure of individual molecules, but the pressure measurement is actually the average value of pressure exhibited by all the molecules. Similarly, we can consider the temperature also. It is the average value of the molecules. So with this, I end this video. Thank you.